Hello, here we will talk about quartile deviation. Quartile deviation is part of absolute measure of dispersions. As we know, measures of dispersion is divided into two parts. One is known as absolute measure of dispersion and second one is known as the relative measures of dispersion. So in absolute measure of dispersion, there are 4 points. First one is the range, second one is the mean deviation, third one is the standard deviation, and fourth one is the quartile deviation. So here we'll discuss about quartile deviation in details. So quartiles means data can be divided in into four regions that cover the total range of observed values. Cut points for these regions are known as quartiles. That means this is the suppose for example this is the data whole data, and there is cut points. There we are going to cut 3 points, 1 2 and 3. So this is known as the q1, and this is known as the q2, and this is known as the q3. If in a line, if data is divided in four equal parts, this is 1, this is 2, this is 3, and this is 4. So that is known as quartiles. So here we can say first quartile is 25%, and between q1 to q2 25%, q2 q3 25%, and above. So this is the, that means whole data dividing in four equal parts, that is known as quartiles. Now few concepts we need to understand. The first quartile, which is q1, is the value for which the 25%, that is means this one, of the observation are smaller, and 75%, which is from here to here, are larger. And q2 is the same as the median. Median, as we know, median divide whole data set in two equal parts. So median q2 equal to median, we can say also 50% observation are smaller and 50% are larger. So this is the 50% and this is the 50%. Now, only 25% of the observations are greater than third quartile. So Q3 is known as the third quartile or upper quartile, and Q2 is known as the lower quartile or first quartile. Now, next points we need to understand. The first quartile Q1 is the first 25% of the data. The second quartile Q2 is between the 25th and 50th percentage point in the data, and upper bound of Q2 is the median, as I said. And the third quartile Q3 is the 25% of the data lying between the median and the 75% cut points in the data. And q1 is the median of the first half of the ordered observation, and q3 is the median of the second half of the ordered observation. This is the key points we need to understand. Now quartile measures some points we need to understand. Quartiles by determining the value in the appropriate position in the rank data. So quartiles gives the positional value in given data. If we have ungrouped data, then first quartile position we can find out n plus 1 by fourth rank value. Second quartile's position we can find out q2 n plus 1 divided by 2 ranked value. En means number of observation in given data. Third quartile or q3 we can find out 3 n plus 1 divided by 4 rank value, where n is the number of observed values. And for example, this is the sample data is given here. We can say 11, 12, 13, 16, 16, 17, 18, 21 and 22. And here total number of observation is n. And if you are try to find out the q1 value, so here n equal to n plus 1 divided by 4. That means 2.5 in position of the rank data. So 2.5 means this first one. First, second, 2.5 lies between somewhere here. So that means 12 plus 13. So we can say use the value halfway between second and third value. So second is the 12 and third one is the 13. So 12 plus 13 divided by 2 will get the 12.5. So Q1 and Q3 are measures of non-central location, and we can say, because as we know Q2 second quartile is equal to median, is a measures of central tendency. Now next points we can find out if same data here we have given, and Q2 we want to find out n plus 1 by 4. So Q1 same way we can find out 12.5, and Q2 we want to find n plus 1 divided by 2, fifth position of the ranked data. So this is the 5. Means once data is given, we need to arrange the data in ascending and descending order, so we can find out the Q2 and Q3, 3 n plus 1 by 4 and 7.4 positions. So 18 plus 21 divided by 2, which is 9.5. This is the Q3 value. As we know, Q1 and Q3 is non-central value, and Q2 is median, is a measure of central tendency. Now another example we can find out, Automobile Association checks the price of gasoline before many holiday weekends. Listed below are the self-services prices for a sample of 8 retail outlets during the May 24, 2004 Memorial Day weekend. So these are the observations. We need to find out the quartile deviation, interquartile range and semi-quartile range. So quartile deviation we can find out. Here we can say arrange data in ascending or descending order, and if data is even, then we can opt this formula n by 4 the observation plus n by 4 1 observation divided 4 n equal to 8. So we can put the just n value and second observation and third observation in given data, second and third. So 30 plus 4, so Q1 value is 35. This way we can find out. Now same with Q3 value we can find out, as we know the formula 3n by 4 plus 3n by 4 plus 1, and same value sixth observation in the given data set, seventh observation given data set, we can take the average and we can find out. And quartile division, as we know Q3 upper quartile minus lower quartile divided by 2 is known as the quartile division. Interquartile range, upper quartile minus lower quartile, uh, that is the interquartile, and semi-interquartile range we can say upper quartile minus lower quartile divided by 2 equal to 40. So Q3 is known as third quartile or upper quartile, and Q1 is known as lower quartile or first quartile. Now we some concept we need to understand, calculation rules. When calculating the ranked position, use the following rule. If the results is a whole number, then it is the ranked position to use, and if the results in a fractional half, then average the two corresponding data values. If the results is not a whole number or fractional half, then round the results to the nearest integer to find the rank position. So these are the concepts we need to understand when we are going to calculate the quartiles. Now, what is the semi-interquartile range? So the semi-interquartile range in short form we can say, sir, is defined as the difference of the first and third quartiles divided by 2. So the first quartile is the 25th percentile we can say, and third quartile we can say 75th percentile. And semi-interquartile range we can upper quartile minus lower quartile divided by 2, and IQR is interquartile range we can say Q3 minus Q1 upper quartile minus lower quartile, or we can say third quartile minus first quartile, and measure the spread in the middle of 50% of the data. And the IQR is measure of the variability that is not influenced by the outliers to the value. Outliers means those are the upper the maximum values beyond the range. And calculating the interquartile range, so this is the kind of, this is known as the box plot. if whole data is given, we have find out. So minimum value, so here we find out the minimum value in given data set. So minimum value to first quartile is a 25%, and Q1 to Q2 is the 25%, Q2 to Q3 25%, Q3 to maximum value 20%. As we know, Q2 equal to median. So interquartile range, we know the formula. This is the Q1, this is the Q3. So this is the Q3 value minus Q1 equal to 27 is the interquartile range. Now the box plots we need to understand. If we have a data and we are going to plot the box plot, so which is the graphical display of the data. So first of all, we need to find out in given data set what is the smallest number of the value in given data set, what is the first quartile values, what is the median value, what is the upper quartile values given data set, and what is the largest value or maximum value in the given data set. Then we can plot the graph. This line is the x smallest value in given data set, and this would be the largest value in the given data set. And this cut point would be the Q1, this cut point is the median, this cut point is the upper quartile or third quartile, and this is the 25% data. Here belong 25% data, here belong 25%, and this is the 25% already we have explained in previous slides. So this is about the box plots and more shape of box plots. If data are symmetric around the median, then the box and central line are centered between the end points. As we know, smallest value and largest values here, and this is the first quartile, third quartile, and median. A box plot can be shown either a vertical or horizontal orientation. So this is the horizontal, so we can also put in vertical line. Now next points we need to understand one example. So previous examples we have discussed as ungroup data, but if we have a group data, then how we'll calculate the quartiles. So for example, systolic blood pressure is given in, and corresponding frequency value is given, and cumulative frequency we have calculated here. Then how to find out lower quartile Q1 we need to find out. So this formula we need to calculate, as we are aware about the median formula. So here we need to understand in median it is n by 2, and if you are going to calculate the quartiles, so because quartile divide whole data set in 4 equal parts, that's why we are dividing here n divided by 4. So so this formula we can apply L plus within a bracket n by 4 minus cumulative frequency divided by frequency multiplied by width of the upper limit minus lower limit of the class interval. So then as we know the median calculation, we can calculate n by 4, 68 by 4, 17. Lower quartiles we can find out from the data set, and L value is given. Cumulative frequency we can find out from the given. Same concept we have to apply as we have calculated median for given for group data set. So all the values we can find out the from the data, and we can finally calculate the uh, lower quartile or Q1. And same way upper quartile Q3, just a basic difference in the formula here 3n by 4. So always remember, if you are talking about the first quartile, so 1 multiply n by 4, second quartile 2 n divided 4, third quartile 3 n divided by 4, and rest concept is same. This one is the, as we divide, if we are going to calculate median, then it would be n by 4. It would be the n by 2, sorry, it would be the n by 4 for median, and quartiles it would be the n by 4. So here third quartile we are calculating, so that's why 3 multiply n 68 divided with 4, which is 51, and rest concept we have to go through the median, and same way we can apply and we can find out the third quartile. Now, next points we need to understand. Once we have done the quartiles, then we need to understand the deciles. So deciles, what is the meaning of deciles? If data is ordered and divided into 10 parts, then cut points are called the decile. Suppose this is the data, this is the whole data we can understand here. And in deciles, whole data set divided in 10 equal parts. This is the first one is the D1. So this cut points is known as first decile. Then second point is known as the third second decile. Same way second third decile, fourth decile, fifth decile, sixth decile, seventh decile, eighth decile, and ninth decile. D9. If whole data set is divided in 10 equal parts, there would be the 9 cut points. 9 cut points. So each one is known as the first decile, second decile, and third decile, fourth decile, and this would be the fifth decile. So this is the meaning of the deciles, means whole data set in divided whole equal parts. Say if we see D5, D5 means this is dividing whole data set in two equal parts. So this would be the equal to the median. We can say median. So as we know, median equal to second quartile, and second quartile equal to fifth decile. So this is the relationship we can develop here. And some formulas, we can useful formula for deciles if we have a group data. So as we know, for median we'll take the n by 2 and quartile n by 10, quartile n by 4, and here we are going to calculate deciles. That's why it is the n by 10. 1 multiply n by 10. Here d5 we are calculating, so 5 and divided by 10, and D7 we are calculating 7n divided by 10 minus cumulative frequency D9. So 9n divided by 10. And rest concept, as we have discussed for median calculation, rest concept would be the same. Only we have to focus on n by 10. Why? Because this is the deciles. Now one last points, percentiles we need to understand. So percentiles means if data is ordered and divided into 100 parts, then cut points are called the percentiles. 25th percentile is the Q1, 5th percentile is the median, 75th percentile of the data is Q3. That means same as we know, median divide whole data set in two equal parts, quartile divide whole data set in four equal parts, decile divide whole data set in 10 equal parts, and percentile divide whole data set in 100 equal parts. There means here it would be the 99 cut points. Here it would be the 99 cut points. We can say this is the P99, and here it would be the P1. So between 0 to first cut point, so each point cut equal parts will take the equal percentage. So 1% means percentile dividing whole data set in 100 equal parts in 1 percentage. So this would be the P50. P50 divided whole data set in two equal parts. As we know, median equal to divide whole data set in two equal parts. Q2 second quartile divided whole data set in two equal parts, and D5 divided whole data set in two equal parts, and P50 divided whole data set in two equal parts. So this is the relationship between median, quartile, decile, and percentile we need to understand. So this is the about percentiles. But once we have group data and we are going to calculate the percentiles, so we need to remember this formula. As we know, for median group data calculation we use n by 2, decile we use n by 10, quartile we use n by 4, and percentile we use n by 100. So first percentile if we are going to calculate, so it would be the n by 10, and 20th percentile we are going to calculate 20 n divided by 100. 50th percentile is 50 n divided by 100, and 75th percentiles it will be the 75th n divided by 100, and rest concept would be common as we have discussed for median. So this is about overall summary about quartile deviations, percentile, decile. So we need to understand. Thank you.